today. So I'll do a quick refresh on the MJP 300W Plus. Then I'll go straight into the enhancements and tools that we're introducing in 3DSprint 2026.1, and then talk a little bit about some post-processing tips that we have. Okay, so just a quick refresh on 300W Plus. Again, we introduced this last October as a follow-on to the MJP 300W. We made some pretty significant improvements, increased the productivity in several different ways. One in the print speed, making SHD, ZHD, and QHD all faster than the prior model. We increased the usable print area on the platform, and also enabled faster post-processing with breakaway supports. Those breakaway supports also lead to lower run cost using less of the support material, and then with less support material to dissolve, that leads to less turnover, less frequent turnover of the post-processing solvents. We also made pretty significant improvement in reliability with a longer life planarizer roller to maintain the consistent print quality, and then updated our cybersecurity to designed to meet the 2027 EU standard. So just a quick refresh there. So let me get into the updates that we've made in the Surface Enhance tool, and then also a couple other things in 3DSprint 2026.1. If you recall, when we launched the product, one of the significant value adds we made in the product was this, what we call Surface Enhance. It's illustrated over there in the image on the right, where you see in each mode printed without Surface Enhance on the left, and then with the Surface Enhance on the right. The main idea behind this function was to reduce the effect of contour lines and to improve the overall surface quality. When we implemented this, we applied that feature the same to all surfaces of the part. That, again, had a positive impact to the contoured surfaces, really didn't have much of an effect on flat surfaces, really wasn't necessary. It also is less effective on very small features. And so based on a lot of customer feedback and some of our own internal testing, we made some improvements to try and simplify and apply those modifications only where it's necessary and relevant. So the approach we've taken in this new version of 3DSprint is there are 3 settings to choose from related to Surface Enhance. The first one is unset. That actually turns the Surface Enhance off for all the surfaces. And you see in the upper right, the white just reflects an unmodified surface. The next option is a thick setting. That's our default. What you see in the image, the middle image on the right, is the black surfaces representing where we've disabled the Surface Enhance. We essentially have eliminated it from all flat surfaces, focusing the benefit on contoured surfaces and then eliminating it from the flat surfaces where it isn't necessary. And then the last one is a thin setting. That's really optimized for part strength in thin geometries. As the price of gold has gone up, a lot of our customers have gone to more lightweight, fragile designs. And so what we're trying to do here is preserve the part strength with those thin geometries. The Surface Enhance just focuses on upward-facing surfaces and is not applied to flat surfaces, the bottom surface, or left or right surfaces on the part. So we're just really trying to minimize the modifications to the part, again, strictly to where it's necessary, and preserve the structural integrity of those lighter weight geometries. So the way to select those different options, in the 3DSprint menu, when you see the part list on the right portion of the screen, you can select a part from that list. You right-click with the mouse to view the menu that's shown here. You select Enhance, and then in that sub-menu, then it has the options for unset, set thick, or set thin. Again, thick is the default setting that you should see on all parts to begin with, but then you have the option to modify either unset or set thin from there. Okay, I've shown this in a previous webinar. One of the things that I want to do here is just provide a little guidance on when the Surface Enhance offers the most benefit. As I mentioned before, it's mostly the contoured surfaces, and it's really going to offer the most benefit when you're using one of the lower resolution modes. So you can see with our XHD on the left column there, we have the XHD mode, and you see quite a higher concentration of parts where this offers benefit. And then as you go to the higher resolution modes, that benefit is less noticeable. So it's really just the one thing I wanted to draw attention to here. And then even as you go to the QHD, really the way where the Surface Enhance is going to offer benefit is when you've got some more continuous, smooth, curved surfaces. Okay, so one of the other really nice tools that we've added to 3DSprint this time around is the Sprues and Runners tool. And the table, what you see is 4 standard geometry options that we've made available here. The runners, struts, risers, and stilts. This gives a little bit of a description of the purpose of each one of those, and the options that you have for each one of those types of geometry. The main thing, the runners, is really the purpose to direct flow to different areas of the part to give better quality casting. The struts for structural integrity and dimensional stability during the process. And then the risers and stilts are very similar. Really, the riser is intended to provide a connection back to a feed sprue or the main sprue that's used in the casting process. Whereas the stilt, it allows a connection to the platform, and the riser is free in midair on the other end. So that's really the main difference between those two. All 4 geometries, you have the option to choose a different cross-section, circle, rectangular, or hexagonal, and I'll get a little bit more detail on that in the following slides. So how you get there is in the main print menu, you select the struts, and then that brings up a new window, which then you select the class from the drop-down menu. So that's strut, stilt, runner, or riser. Then you can select the cross-section, so circular, rectangular, hexagonal. And then the last feature there is where you can get into taper and tip parameters. And I'll show you a few examples of that here. So this really gets at just the aspect ratio parameter. So in this case, right, there's a riser off of the ring. The image that's closest left or forward is just a standard circular profile. And then by changing the aspect ratio from 1 to 0.5, you get the other image where it changes it to a more of an elliptical cross-section. So pretty simple. Then this is really an examination of the different options on the tip geometry. So you can see the first image is just the default. So it's just a straight cylinder. It runs into the part. In the second image, there in the middle, we've added a fillet to the connection with the part. The third image, we've actually turned that normal to the surface of the part. Then in the lower row on the left, added some offset and depth to the tip, so you can see like a straight cylindrical projection off the surface of the part. The last image there is just a modification to that offset, so it's a little bit less of a cylindrical projection as you go to that part. So those are just some of the functions that are available to alter the geometry of the tip as it interfaces with the part. One other nice feature is you can use our engrave features with any of these added geometries. So if you go to the prepare function and select the engrave, then that gives you the option of adding in some kind of an identification and placing that on that new feature. And you have the options of making that an extrusion or an entrapment, making the text go inward or outward, any of those kind of options. So again, nice feature to apply identification on a part that, a piece of the geometry that doesn't end up on the final part. Okay, so that's it for the new features and tools in 3DSprint. So the last thing that I want to go through, just some post-processing tips. This is a modification of a slide that I provided in a prior webinar as well. You know, most of our customers are using isopropyl alcohol as the way to dissolve the support wax in the post-processing. It's the cheapest, it's the fastest, but there are some drawbacks and some sensitivities that can happen if you don't pay close attention. And so extended time in that pure IPA bath can alter some of the mechanical properties. If it's left in there way too long, it can end up making the part a little more brittle. Some of this white film can develop on the surface, which may lead to some surface defects on your casting. So really some of the initial recommendations that we have is, you know, using breakaway supports to reduce the time in the IPA to dissolve the support wax, and that shortens the exposure of the build wax to the isopropyl alcohol. The other thing, of course, is paying very close attention to the bath, and as soon as the last bit of support wax is dissolved, then removing those parts from the bath. One thing I'll say is, you know, all of our customers have a lot of experience with post-processing. A lot of them have done their own optimization. A lot of them know more about post-processing than we do because they're doing it every day as part of production. So really the intent here is, as we've heard some feedback about some of the sensitivities that people have seen, we're trying to do some options that may help make for a more robust process. There are two main alternatives that I want to highlight here. Well, we'll just walk through the workflow real quickly. So obviously you have your printed platform completed. You move on to removing the parts from the platform. That can be done either in the freezer, which is applicable for most jewelry parts where there's a small surface area, contact with the plate. Hot plates can be used for some of those larger contact area parts. So whichever option to get the parts off the plate. Then the top option, the IPA, 99% IPA as the primary bath. That's what most customers are using. Those that have restrictions for IPA sometimes are using the VSWR. So that's the VisiJet support wax remover that we sell. Then from there, what you can do is apply a post dip with any one of the four options that we've got there. So there's a post dip for just 1 second in a bath of Easy Rinse C, which we also sell, or pure delimiting, which should be commercially available. Again, it's a very quick 1 second dip of the parts in there, and that can take care of some of that white film and help with the surface quality of the part. From there, you take it to a water rinse and then do a light compressed air or overnight dry to finish them off. The other post-dip options there are using a blend of, again, that 99% IPA, either with 10 to 20% mineral oil or 10 to 20% Easy Rinse C. I know a lot of our customers use some mineral oil in their process, so that tends to be readily available. Again, the Easy Rinse C is something that can be purchased from us. But in those cases where you're using a blend, it would be a post-dip for something on the order of 10 to 60 seconds, then can go straight to the compressed air or overnight dry to finish off. So those options would be in the case where you're using, again, the IPA, 99% IPA or the VSWR as the primary bath for dissolving the wax. Just doing this this quick post-dip step to help remove that white layer and improve the surface quality of the part. The lower options there are blends, again, under the primary bath. The lower two options are adding either PPG, 10 to 20% PPG, or 10 to 20% water to 99% IPA. In those cases, it actually gives a little more robustness to the time in the bath. So it reduces some of that sensitivity. If the parts are left in the bath for a little longer than beyond when all that support wax is dissolved, there's a little less sensitivity and less impact to the surface quality of the part. So in those cases, with the additives, taking the IPA, adding the 10 to 20% PPG or water, then once those are done, once all the support wax is dissolved, then those can go straight to light compressed air or overnight dry and finish with the process. Okay, so this is just a little more detail on each one of the different options that was proposed on the previous page. Just a tabular version of that flowchart. There's a lot of other notes down there below the table to give some more information. I'm not expecting somebody to be able to read this very quickly during this presentation, and I won't read through them, but this will be added to our best practices documentation for reference in the future. This is in tabular form, looking at the comparison of the benefits of the pure solvent versus the additive blends that we talked about versus doing the post-dip. And in the left column there are kind of different benefits to each one of the options. So the speed of the process, the cost, fine feature distortion, et cetera, et cetera. And the green just representing this would be a best option for that particular vector. Yellow-orange color just representing maybe this would be a less than optimal for that particular aspect of the process. There's a bunch of notes down at the bottom, and this will be another document that we will add to our best practices. In closing, 300W plus, we had the enhanced surface quality, the high productivity, lower run cost, high reliability, cybersecurity, and protection of the data. And then we've come in with just some enhancements here with 3DSprint 2026.1 that introduces some options for simplification of the surface enhanced feature, and then adding in those sprues and runners tools that I went through. And then for post-processing, really the intent is to just provide some robust alternative methods, and we'll make sure we get those into the best practices documentation updates.